So routing in general in web apps maps your URL to behavior in the app. In the case of React Router, it specifically maps it to specific components. So you write rules saying if the URL looks like this, render this component. In a static web page or static website, how does this work? How does routing work? It's pretty straightforward. They're actually just paths, right? So if it's /index.html, you just load the file index.html. If it's about.html, you just grab that file. You don't need any special rules for that because they're actually just directory paths. But most of the websites we visit are actually apps. They're not just loading files from the file system. They're actually running big programs and sending us the output of those programs with our specific flight information or our specific Instagram stories or whatever, moments or whatever the crap they're called. Are those both things? Are the moments and stories, are those both Instagram things? One of those is an Instagram thing. Moments is a Twitter thing. That's right. Okay. So, yeah. So, to get started, we need to add React Router DOM to a project. You don't need to do this right this second. We'll do it when we actually start adding routes. React Router DOM, not just React Router, because, again, it could be web or native. So React Router DOM to add it to our project. And then in that one React DOM render call that we make inside index.js, instead of just passing it your app component, you now pass it this React Router component. And then you wrap your app component in that. So it's what's called a higher order component. A higher order component, really that's just a pattern. It's not exactly part of the React API. It's just a thing people do because it gets you good results. Basically refers to a component that instead of actually doing any UI stuff itself, which is what components are supposed to do generally, it just returns a new component. So when you wrap your app component in the router component, it returns a slight variation of your app component with some additional props and so on. So that's what a higher order component is very briefly. We'll see it in practice soon. So that's how you get started. And now React Router is going to be available inside our app just because we rendered it that way. Then we have to define some routes, which we do with a route component that is built into React Router. So let's look at that top one. Route path equals /widgets. Component equal widgets. What do you suppose that does? If our URL matches /widgets, it renders the component widgets. Piece of cake. Now that would also match /widgets/45 or /widgets/donkeys. That is still a match. If you don't want it to match stuff like that, then you need to use the prop exact. So in the second example, that would match the path /stuff, but not the path /stuff/45. Another difference between these two examples, in the top we pass a component prop with the name of a component and it just renders that component. Instead of just naming a component for it to render, you can also pass it some JSX. Any number of reasons you might want to do that. One could be because it's just something very simple, like an H1. You just have like one line of JSX you needed to do. Or what if you needed to pass a prop to the component you're rendering? In the top example, we can render the component widgets, but we can't pass it any props. If we used a render function, like in the second example, then we could pass it props because we get to write the JSX ourselves. But they're effectively doing the same thing. You can either just tell it the component to render, or you can tell it some JSX to render when that path is matched. You dig? It's not too tough. We'll see. So then you need to be able to link to these new routes. You could just use normal links, or you could use the link and nav link components that are built into React Router. The top example is link. You just tell it what to link to. You don't use href, you use to. Navlink, the difference is the API is exactly the same. You use them exactly the same way. The difference is if you're already on /party, it will add a class name of active to that link. So if you want to keep track of, if you have a menu that's going to persist on every page, and it's going to show a link to the About page even if you're on the About page, but you want some indication that you're on that page, then you could use navlink, and it will put a class name of active on that link. So you can style it differently from the others, which we will also see. Not too tough. Now sometimes you want something like /widgets /45. Maybe /widgets is a page that lists all the widgets, or /notes lists all the notes, whereas /notes /45 loads a specific note. So you need to be able to write routes that do that too, and for that you need params. So when you're using React Router, each component has access to a set of props that React Router adds. And you can use those to get a little bit more information. So here we link to /about/Bob. And then we define a route with a path of /about/:name. So that is a param, :name is. By sticking a colon in there, it's telling it, I'm not looking for the exact phrase :name. I'm just looking for something there. That could be anything. And you can add regular expressions and stuff to make sure that they're digits or something like that if you need to. And then inside my user about component, which is what that route points to, I could find out what they used as the param name by using props.match.params. So again, React Router just automatically passes in some new params, props to your component if you got there using the router. Among them, match. And then match has a key in it called params that has whatever route params were passed in, if any. We'll see it in practice. Not too tough. There's also a history object that is passed in as a prop. It is very much like the browser history object that is passed in HTML5, but this is a Reactified version of that. Feel like reading today, Pooja?
Sure. History keeps track of all users' navigation over time. It can be used to programmatically navigate without using links. There are many useful history methods: push, go back, go forward, go then, and block.
Yeah. So if you want to navigate to a new page from where you are, you could use push and pass in a path, and it will just add that to the end of your browser history. Go back basically pops something off. Go forward, the forward button, right? So they'll simulate the back button and the forward button. Go, and then a number will go that many levels back in your history. Block, if for some reason they've tried to navigate to a page and you want to stop them from doing that, you could do that using block. We're not going to use that in class or anything, but it's there. So it's just this object we can use to programmatically change which page they're on, if we want to do that in response to some action occurring instead of just by clicking on a link. For example, suppose we're making a Twitter client and we have a route for composing a new tweet. So maybe that's /compose or something. After they hit submit, they don't then click a link to go back to their timeline, right? It just happens. So we programmatically want to send them back to their timeline after they finish composing the tweet. So we need to do it programmatically, hence the history object. So that's React Router. We're going to use it in a brand new project. Woohoo! Anybody ever used fetch? Yeah, what's fetch? To make requests. It is indeed. To make asynchronous requests. Yes, JavaScript, after all these years, is still trying to make fetch happen. So, that heading is wrong. This is not history. This is fetch. Tell us all about fetch. You made eye contact. What do you think, Grace? What's fetch?
Fetch API provides a JavaScript interface for accessing and manipulating parts of the HTTP pipeline, such as requests and responses. It also provides a global fetch method that provides an easy, logical way to fetch resources. I have no idea what that word is. Across the network.
Asynchronously.
Okay.
Yes. Fetch resources asynchronously across the network. So, if you remember your day one presentation, I talked a little bit about XHR, aka Ajax, which was the old way to do asynchronous requests. Fetch is a lot easier. So there is this function, this global fetch method, that's available everywhere that you can use to make asynchronous HTTP requests. What the heck am I talking about with this asynchronous business? You know what that means? To put it very simply, load a new URL without refreshing the entire page. Without leaving the page you're on, make another request. We do it all the time. We didn't used to be able to do it at all. But we've been able to do it the hard way for quite a while now, for approximately your entire lifetimes, now that I think about it, since about 2000. But now there's fetch, which is just a lot easier. So here's the API. You pass fetch a URL. And maybe that's all you do. That's fine. But what that does is return something called a promise. And a promise, we can then basically, I have a good definition of this that I didn't write down, so I've forgotten it because it's been a year. But basically, promises let us tell it to do something when it finishes. So since fetch is happening asynchronously, it's happening in the background. So whatever line of code comes after fetch is going to run as soon as we run fetch and not wait for the response to come back from the server. So you can't just say, do something with the results. The results won't be there yet. But since it returns a function, then we have access to a method called then, which we can pass a function that will run only after it is finished. So we write a little function that does something with the response. It just parses some JSON from the response. And that happens asynchronously. So we can call .then on that. And console log something. What about .catch? What'd you guess that does? We've seen the word catch once before in class. What did it do then? Yeah, it's error handling. If the things above it don't work, then that happens. Yeah, so if for some reason fetch fails, then we'll run the catch block there. Piece of cake.